Okay, so welcome back to another video. So today we have a algebra equation that we would like to solve for. We want to find all x in the real numbers such that the floor of x plus the floor of 2x plus the floor of 3x is equal to 4x. So in a situation like this, especially when you have something of the floor function slash the greatest integer function, we can all see at the speculation at first that by definition the floor function is supposed to be in a form of an integer. So if you take a sum of these integers, then that would have to mean the right side has to be in a form of an integer as well. Well, depending on where we have x on the reals, we're going to have to analyze this a little carefully, where in a situation we have to break this up into cases. So with that being the case, that's actually the main takeaway on understanding on how to solve equations like this. For example, actually there was something similar to where the left-hand side is the same thing written as the way it is. So floor of x plus the floor of 2x plus the floor of 3x. And I forgot what the right-hand side was, but there was an old video I did on that a long time ago. So if you want to check that out, that link will be in the description below. With that out of the way, there's something more I need to discuss. That's basically the whole gist of that. So why don't we actually just jump right in? So, of course, as mentioned, the floor functions, the floor of x, the floor of 2x, and indeed the floor of 3x, those have to be in a form of an integer. So, with that being the case, that everything on the left-hand side, the floor of x plus the floor of 2x plus the floor of 3x is therefore, of course, it's equal to 4x, but that right-hand side is going to be in a form of an integer, so I'll just call this n, so equals to n, such that n is also in a form of an integer as well. So if I were to solve this by itself for x, so that would have to mean that over here that then means x is going to have to equal n divided by 4. So with that the case, let's actually now break this into 4 different cases. The reason we do this into 4 cases just so everything in terms has to be in a form of an integer, but that's divisible by 4. So there's actually some cases that we have to look at. We can look at this in terms of an integer for 4k plus 1, 4k plus 2, 4k plus 3, or even just 4k for that numerator we can just fill in and substitute. So with that, let's actually start out with our first case. So case number 1 we're going to deal with is actually where the numerator n is going to be 4k. So case 1. So if I put this back in, so I have x is equal to 4k divided by 4, therefore it's just equal to k, such that 4k is an integer. So with this being the case, so I've actually just put in x back into everything over here, so for k. So this implies that the floor of x is going to equal the floor of k, which indeed is just going to equal k. Then I have the floor of, 2x is therefore equal to floor of 2k, which that means that's going to equal to just, 2k. Then next is going to be the floor of 3x equals the floor of 3k, which therefore is going to equal to 3k. And then lastly, I have 4x is just going to equal to 4k. Okay, so with this in mind, so now I can actually just substitute back into our equation over here. So then that means I have k plus 2k plus 3k. Add those all together, we have that this is equal to 6k, equal to the right-hand side 4k, and then if I just solve for k by itself, so we can see that I can just subtract the 4k, so I have 2k equals to 0, then divide the 2 to both sides, so this implies that k is going to equal 0, and if I plug k into 0 back into over here, guess what? We have that x is equal 0, which that is in a form of an integer. So x is going to equal 0, and so therefore this is our first solution that we have come up with. Okay, so let me actually box this with a different color instead. All right, so moving on, we got case number 2. So case 2 is that we're going to let the numerator be 4k plus 1. So let's see, x equals 4k plus 1 divided by 4, which that's the same thing as k plus 1 divided by 4. Okay, so, and of course that's for k is some integer. So now if I put this back in for everything, so that means now the floor of x is therefore just equal to the floor of k plus 1 over 4, then therefore that's still just going to equal k. Now if I put in 2x, so 2x then equals, so multiply the 2 to all this, so it's 2k and then plus 1/2. Therefore that is still going to equal to just 2k if we take the floor. Next I have 3x, so that means multiply the 3 to all this, so I have 3k and then plus 3 over 4, which that is still going to equal 3k, and then I have 4x, which therefore is just going to equal to 4k, and then add this with 1. Okay, now that we have all that, now let's actually just plug this back into the equation. So I have k, add this with 2k, and then add this with 3k. So all that up together, so that's 6k, and then set the right-hand side for x, which is 4k plus 1. Then that has to imply that, let's see, if I subtract the 4k to both sides, so I have 2k is equal to 1, and so therefore k is equal to 1/2. However, that does not satisfy since we want this in a form of an integer, so that means no solution for this situation over here. So that means now we can just move on to the next case, which is going to be, we have the 4k plus 2 for our numerator. Next is moving on to case 3. You kind of see the pattern over here, so x, but I'm still going to work out everything in full just for, your understanding. So x is going to be 4k plus 2 and divided by 4, and so that would have to mean that that's the same thing equals to k plus 1/2, such that k is in a form of an integer. So now that would have to mean if I plug the floor of x into all this, so floor of x, therefore it's going to be, the floor of k plus 1/2. Of course, that's still going to equal to just k. And then next I have the floor of 2x, so that means that's just going to equal 2k and then plus 1, which of course, all that is still integer, so I have 2k plus 1 over here. So now I have the floor of 3x, so therefore that means that's going to be 3k, and then add this with 3 over 2. So if I take the floor of that entire thing, that's still going to be 3k plus 1. And x, I have 4x, which therefore if I just plug that in, that's just going to be 4k plus 2. So putting this all together, so now I just take the sum, so I have k plus 2k plus 1, and then add this with 3k plus 1. That entire side is going to equal to just 6k plus 2. Set that equal to 4k plus 2, and so therefore that's going to yield us with just 2k equals 0. Then solve that, then that means I have k is equal to 0, and so plug this back in. So that means I have that 0 back into over here. That's going to be x is going to equal to just 1/2. So and now we just have one more case to finish up, and then for that, I'm actually just going to erase this side to occupy the final case. All right, so the last one, I have case 4. This is going to be for 4k, x is equal to 4k plus 3, then divided by 4, which that's the same thing written as k plus 3 over 4, for k is an integer. So if I just put this back in, so let's see, I have the floor of x is therefore just going to be the floor of k plus 3 divided by 4, which of course that's still just going to equal k. Next I have 2x, put this back in, so I have 2k, add this with 3 divided by 2, which that's still going to be 2k plus 1 when you take the floor of this entire thing. Next I have 3x, the floor of 3x, that's going to be, 3k, and then add this with 9 divided by 4, and you take the floor of that entire thing, I have 3k plus 2, and then if I put 4x, so that means just substitute this back in, I have 4k and then plus 3. So now put everything back together, so I have k plus 2k plus 1, and then add this with 3k plus 2. That entire left-hand side is going to equal to just 6k plus 3. And then this is still equal to 4k plus 3 on the right-hand side. And if you solve for k by itself, we're going to have that k is going to equal 0. And we just put this back in since k is still an integer back into over here. So that means now x is going to equal to just 3 over 4. And so with that, we are finished, and that concludes the answer. So we actually have 3 different solutions that actually satisfy the following. So in overall, so x is going to equal to simply just 0, 1/2, and 3 divided by 4. As we know that the case, the second case, there's no solution since we ended up with a rational number. So with that, these are our solutions over here that satisfy the following, and you can actually, verify yourself by checking and inputting each of these solutions there to get exactly the same result as it is. So with that, there we have it, and that's pretty cool if you ask me.